I think so. My screen was shared and my voice is audible, right?
Okay.
Okay. Now, see, in our last class, I think so. We discussed on the completions of the areas. That means completions of the area and volume, right? If you know the area, you can able to easily calculate the volume, as you know, right? Here we have so many parameters. I mean, so many different types of geometrical figures was there, right? So that means for the given area, we need to split in a possible way of geometrical shapes, not in only the triangle or right angle triangle, right? Here, what we are doing, so possible way of splitting into the possible geometrical shapes. That means rectangle, parallelogram, right? So triangle, if in case of possible circle, that means if there is any circles curve was there, in that case we can able to go for the circles, right? In case of rhombus, whatever it may be like that, right? But whereas coming to here, most of the cases that will be there in triangle and trapezium. Okay, here they have given the how we are going to calculate the area for this trapezium or rectangle, whatever it may be. So we have a one of the trapezium was there. Why? Because most of the cases it will be there like that, right? So this trapezium we can able to convert into the one rectangle and one triangle. Again, we have to split the trapezium, right? So that are the cases will happen in the trapezium. That's why we have to take an example of trapezium here. See here, they have a general method was there. How we are going to calculate the area. So these are the various methods by completion based on right field measurements. So directly we are going to measure the distance between the one to another. Based on that, how we are going to calculate the area. That means one of the method as you are going to done in your laboratory, right? So that is method by dividing the area into a number of triangles. Okay. So one of the thing is by dividing the area into a number of triangles. And second one is by offsets to the baseline. By offsets to the baseline. Next, by latitude and departure. So last class we have given some small brief explanation about that. So what is the latitude and what is the departure and meridian distance. So here we have two meridians. One is a double meridian and double parallel distance. Okay. Next coming to the by coordinates. As you know, it is a very easy as compared to the remaining things and give the very accuracy. If you know the coordinates, you can able to pick out the point where it was, right? So based on the one meridian lines, that means so based on x or y, we can they have given the one of the coordinates for the each and every point. Based on that, you can able to easily click and form your triangles and calculate the area. So this is the easy. And next coming to the so these are will coming under field measurements. Next, by completion based on the measurement scaled from a map. Okay, so that means you are not going to visit the field, visit the site. So what we are doing, just based on the map, you are going to tell the total area of the given field. So that is a one on another example. That means if the map was shrinked due to temperature effects, right? Otherwise, it may expand. What will happen? What you are going to calculate the area will be wrong. Why? Because there is some shrinkage and expansion was there on the map. Okay, so that will happen. That is one of the error will occur in the maps. And next, finally, what is the third one? Is by mechanical method, usually by means of planimeter. Okay, so planimeter also we are going to calculate the area, I mean calculate the distance as well as angle on the map itself. Okay, now let us discuss on the first one, computations of the area by back field measurements. As you know, what is the area formula for triangle? That is a half into base into height. If the angle, I mean it shows us some angle means, then we can able to use as a, that is a half into base into sine of angle C. So what is the S here? Already I have given. If you know the three sides of the triangle, we can use as a another formula. That is the area equals to square root of S into S minus A into S minus B into S minus C. So there is a formula as a given. So what is the S means? That is the half of the perimeter, half of A plus B plus C. That is the three sides of the triangle distance. Okay. How we are going to calculate the area means, so this is the method, area computed by subdivisions into triangles. So here we are going to divide the triangle based on one baseline, otherwise based on one particular point. That is meant by gradation method, otherwise by using of baseline. So by using of baseline means that is coming under offsets. Okay, so that we have done in our laboratory. Okay, so here we have only one of the point. There is a O on center of the this complete points A, B, C, D. Right? What we are doing is we need to calculate the distance between the O to E, O to B, O to C. Like that we have measured. Okay, and calculate the area. If you know the O to, if I mean here we have one of the triangles O A B. Right? You know the distance of OA as well as OB, and also you measured the distance between AB also. There is another side of the triangle, right? So there is a triangle. How we are going to calculate it? There is enough. The if two sides and one included angle, understood? If two sides and one included angle of a triangle is measured, then the area formula is half into A, that is the one side, and B is the other side, sine C, that is the angle. Okay, so this is the formula we are going to calculate by using of two sides and one angle. That is not a right angle triangle. That's why we are using this formula. Okay, and if you know the three sides, we can able to use this formula. It is not visible, as you know what is the formula, right? S into S minus C into S minus B into S minus C. So what is the formula here? Okay, next, coming to the area. Area from offsets to a baseline, offset at regular intervals. See here. So again it was classified. I mean here, based on the offsets we have different methods also. One is the mid ordinate rule, right? Average ordinate rule, trapezoidal rule, Simpson's rule. Okay, mid ordinate rule. Mid ordinate rule. What we are doing means, this method is used the assumption of the boundaries between the, so between the extreme ordinates of the successive points, successive divisions. Okay, so that means here we have one of the baseline was there. The baseline was divided into a number of divisions. So that means the complete baseline was divided into a number of equal. That means the distance between the division to division will be same. Okay, so number of divisions will be same, are measured at the midpoint of each division. So these ordinates are measured at the midpoint of the each and every division. Okay, so that is we have indicated, that is meant by O1, O2, O3. Like that we have indicated. That is one of the baseline, and we have split it with the equal distance of the divisions, and find the ordinates at the point of at mid for each and every division. Okay, the ordinates at the midpoint of the each division, and the area formula, right? Area formula, area as we are indicated with the delta, that equals to average ordinate multiply with length of the base. So what we are doing means we are going to average the ordinates, right? So O1 plus O2 plus so on On divided by n, right? Divided by n, multiply with its length L. Okay, so average ordinate means we have a from ordinates on O1 to On divided by n terms, multiply with L, right? So as you know, what is the L? L is the length. Okay, so here L by N we are taking as a, that is the division D distance. Total length is L. We have divided with n divisions. So L divided by n, just then you automatically what you are getting. So each division distance, how much you have divided, right? That will be getting. That is the L by n equals to D. O1 plus O2 plus O3 so on On multiply with D. So that is the final formula, that equals to, so O1 plus O2 plus so on On, that we have written as a summation of O. Okay, n equals to 1 to n terms. Okay, D equals to summation of O. That is the formula for the average ordinate rule. Sorry, mid ordinate rule. Right? Next, coming to the average ordinate rule. Maybe the formula is not clear here. Right? I will tell you. In the average ordinate rule, what they are doing means completely. So for the each and every ordinate, they have to take an average. So first of all, average the successive ordinates, right? Like that they have to take an as an average here. So what is the difference from mid ordinate rule and average ordinate rule means? Here they are not going to consider, only n terms was considered in the mid ordinate rule. Whereas coming to here, we are going to consider n plus 1 terms. Okay, so same formula, but initially it starts with O naught. O naught plus O1 plus O2 so on On divided by n plus 1 multiply with L. Okay, so that means what is the formula? L by n plus 1 summation of O. Okay, L by n plus 1 summation of O. That is the formula for average ordinate rule, such as same figure. So what is the figure we have taken for the mid ordinate rule? Same, but here they are going to consider as started with O naught. Okay, and next coming to the trapezoidal rule, right? In the trapezoidal rule, in the ordinate or average ordinate rule, they have considered as a ordinate at the center of the division, right? But whereas coming to in the trapezoidal rule, they are going to consider at ends of the divisions. That means start before going to start the division and end with end the point, right? So they are going to calculate the ordinates at the starting point and ending point, right? So as you know, what is the formula for trapezium, right? So trapezoidal formula is division d by 2, that is the base, right? D by 2 multiply with h1 plus h2. I mean h by 2 into a plus b. Here instead of a we have a o naught plus o1 was a, right? And that means average of these 2 points o naught plus o1 divided by 2 multiply with division distance d. Okay, so like that we have calculated for each division. Okay, so there is a, if in case of delta 1 is, what is the formula delta 1 for each division, first division, right? So that is the o naught plus o1 by 2 into d. What is the delta 2? O1 plus o2 by 2 into d. That means what will happen is the o1, right? O1 అనేది మనకింది డెల్టా 1 లో o naught plus o1 divided by 2 వస్తా ఉంది. See here, just assume the delta 1 is, this is the o naught, right? And this is the o1 divided by 2 into d, right? And delta 2 is o1 plus o2 divided by 2 into d. That means ఇక్కడ ఆల్రెడీ మనకు డెల్టా 1 అంటే ఫస్ట్ డివిజన్ యొక్క ఏరియాలో ఓ నాట్ వచ్చింది, ఓ1 వచ్చింది. ఇక్కడికి వచ్చేకాడికి ఓ1 ఓ2 వచ్చింది, ఇది సెకండ్ డివిజన్ కి. అంటే ఓ1 వచ్చి మనకు రెండు సార్లు వస్తా ఉంది, రైట్? సో 2 times గా మనము యావరేజ్ చేస్తున్నాం ఇక్కడ డెల్టా 1 డెల్టా 2లో. అండ్ నెక్స్ట్ డెల్టా 3కి వచ్చేకాడికి ఏంటి, డెల్టా ఐ మీన్ ఓ2 ప్లస్ ఓ3 డివైడెడ్ బై 2, అంటే డి ఇస్ ద కామన్, రైట్? అండ్ డివైడ్ బై 2 ఇస్ ద కామన్ ఫర్ ఈచ్ అండ్ ఎవ్రీ డివిజన్. కాబట్టి మనకేంటి ఓ నాట్ అంటే ఫస్ట్ వన్ లాస్ట్ వన్ రిపీట్ కాదు, ఇంకా రిమైనింగ్ అన్ని రిపీట్ అవుతాయి, రైట్? సో దట్స్ వై వాట్ ఇస్ ద ఫార్ములా ఫర్ దిస్ ట్రిపెజాయిడల్ రూల్ మీన్స్ డెల్టా ఈక్వల్స్ టు ఫస్ట్ అండ్ లాస్ట్ డివిజన్, ఆ రెండు మాత్రమే ప్లస్ గా రావడం లేదు, రైట్? సో దట్ మీన్స్ వీ హ్యావ్ టు యావరేజ్ ఫస్ట్ అండ్ లాస్ట్ ఆర్డినేట్ ఓ నాట్ ప్లస్ ఓ1 డివైడెడ్ బై 2, రైట్? సో రిమైనింగ్ అన్ని టర్మ్స్ కి 2 times వస్తా ఉన్నాయి కాబట్టి మళ్ళీ డివైడ్ బై 2 చేయకుండా, సో బై అడిషన్ ఆఫ్ రిమైనింగ్ ఆర్డినేట్స్, దట్ మీన్స్ o1 o2 o3 ప్లస్ సో ఆన్ on minus 1 whole multiply with d. Okay, so this is a trapezoidal rule for calculating the area. Okay, next coming to the Simpson's one-third rule. Already we have discussed, right? So what is the Simpson's one-third rule means? First and last ordinate, we are going to average of first and last ordinate, first ordinate plus last ordinate plus 4, right? 4 multiply with odd ordinates o1 plus o3 plus o4 so on on minus 1. Okay, 4 multiply with odd ordinates plus 2 multiply with even ordinates whole multiply with d by 3. So Simpson's one-third rule. Simpson's one-third rule means we are going to calculate the area. I think so. In the previous class, I have given you one of the figure example, right? Instead of trapezium, here we have a one of the parabolic curve was there, right? In that case, what we are doing is we are just drawing a line, the linear line at the exactly mid ordinate. So what is the mid ordinate exactly height? We have drawn a one of the line parallel to the of the DC. I think so. I have shown where it is. ఓకే. ఇమేజ్ ఎక్కడో మిస్ అయింది. దేంట్లోనో చూపించాను. ఓకే. వాట్ అవుతుంది. సో మీకు నిన్న ఒక ఇమేజ్ చూపించాను కదా ఒకసారి ఆ ఇమేజ్ చూడండి. సో జస్ట్ మనం ఏం చేస్తున్నాం అంటే ఒక రెక్టాంగిల్ ఫామ్ చేస్తున్నాం, రైట్? ఐ థింక్ సో దీంట్లోనే ఉంది. దీంట్లో కూడా లేదు. See here. So this is one of the trapezium, right? That means actually this is a curve, parabolic curve. In that case, we need to calculate the area. Okay. See here. That means actually figure and this is a ordinate O1. This is a O naught, right? This is the O1. here you have a at the midpoint we have one of the line. O3. Sorry, one light. See here. So this is the ordinate from here to here. That means from here to here, the ordinate is O naught, and the O1 is from here to here. The curve will be like this, and O2 వచ్చి మనకు ఇక్కడ నుంచి ఇక్కడికి ఉంది. So this look like a one of the trapezium, and this is a parabolic curve, right? సో ఈ పారాబోలిక్ కర్వ్ ని క్యాలిక్యులేట్ చేయడానికి జనరల్ గా మనకు 2/3 ఆఫ్ ఇట్స్ బేస్ ఇంటూ హైట్ ఉంటుంది జనరల్ గా, రైట్? సో అంటే ఇక్కడ ఏంది మనకు దిస్ ఇస్ ద డిస్టెన్స్ ఆఫ్ డి వన్ డివిజన్ అండ్ దిస్ ఇస్ ద డిస్టెన్స్ ఆఫ్ డి ఫర్ అనదర్ డిస్టెన్స్, అంటే టోటల్ డిస్టెన్స్ ఇస్ 2d. ఓకే, సో అంటే ఈ కర్వ్ ఏదైతే ఉందో ఈ కర్వ్ ని క్యాలిక్యులేట్ చేయడానికి బదులు మనం ఏం చేస్తున్నామంటే ఇది ట్రెపీజియం, రైట్? సో దీనికే ప్యారల్ గా అట్ ద సెంటర్ మిడ్ పాయింట్ దగ్గర మూవ్ అయ్యే విధంగా నేను ఇంకొక ప్యారల్ లైన్ డ్రా చేసుకున్నా. ఈ ఓ నాట్ ని ఎక్స్టెండ్ చేసాం, ఓ నాట్ ని O2 ని, రైట్? సో ఇప్పుడు మనకి ఏంది, వాట్ ఇస్ ద డిస్టెన్స్ హియర్? ఈ డిస్టెన్స్ ఎంత ఎక్స్టెండ్ చేసాము అంటే O1 మైనస్ O0, రైట్? O1 minus O0 చేస్తే then you will get this distance. So such a same thing here. What is the A, B, C, D? So just assume this is a point of A and this is a point B, right? And this is a here C, this is a D, and here E. Okay, just assume. So these are the points E, F, G like this. So these are the lines here E, F, G. Okay, if you want to know the area of this trapezium, right? So what is the area of this trapezium? As you know, you have a two O sides. Instead of A plus B is O0 plus O2, right? So the other sides, average of these two sides, that means O0 plus O2 divided by 2 multiply with distances from here to here is 2d. So that is the area formula. O0 plus O2 divided by 2 into 2d. Okay. Next, coming to the area of DFC. See here, area of this portion, this curve. Okay, area of this curve portion. So what is the area of that area of segment? That means parabolic curve, right? What is it, man? Okay, so area of this element. అంటే మనం ఏంటి ఆల్రెడీ ఈ ఏరియా క్యాలిక్యులేట్ చేసాం. I need to calculate the remaining, I mean this area, right? So what is this area means? So actually what is the formula? 2/3 of, right? So 2/3 of height, right? So this is the letter of, here you have given you one of the lettering. So this is the F, as you know already we have integrated, and this is the H, right? FH multiply with distance of A to B, that means the horizontal distance. Generally what is the formula for area of triangle? Means half into base into height. Instead of that, here the area of this parabolic segment we are going to calculate the area of 2/3 multiply its height and base, right? Okay, 2/3 height is O1, total O1 minus of O0 plus O2 divided by 2, right? So O0 O1 minus O0 plus O2 divided by 2. So there is this height, and as you know, this distance is 2D. Multiply with 2D, then you will get the value. Like that, we have calculated. And what is the final formula for the Simpson's rule means delta equals to, that is the area, right? D by 3. So each division distance is D by 3. Okay, D by 3 multiply with O0 plus ON. That is the first and last term. With addition of that, 4 multiply with even ordinates plus, sorry, 4 multiply with odd ordinates plus 2 multiply with even ordinates. Okay, next, offsets at irregular intervals, right? Offsets at irregular intervals. No need to go for the measurements of volumes. That is not important. I think so. I have removed it from your survey also, right? Next topic is area. How we are going to calculate the area for offsets at irregular intervals. That means ఇంతసేపు మనం ఏం చేసాం, రెగ్యులర్ ఇంటర్వల్స్ విత్ ద సేమ్ డిస్టెన్స్ ఆఫ్ డి యూజ్ చేసాం, right? So that's why we have used it as a common thing for the each and every ordinate has a d distance. Next, coming to the irregular intervals. Irregular intervals means one division is d1, another distance is another division distance is d2, like that, right? In that case, we need to calculate individually. So this is the formula for trapezium. So that is division height h బదులు మనకి d1 ఉంది కాబట్టి d1 by 2 into, so successive I mean ordinates distance o1 plus o2, right? సో అలాగా మనం ఏం చేయాలి, సపరేట్గా క్యాలిక్యులేట్ చేసుకోవాలి. ఇఫ్ ఇన్ కేస్ ఆఫ్ ఇట్ హ్యాస్ ఏ ఇర్రెగ్యులర్ ఇంటర్వల్స్. ఓకే, ఇర్రెగ్యులర్ ఇంటర్వల్స్ ఉన్నప్పుడు మనకు, సో దిస్ ఇస్ ద ఫార్ములా ఫర్ క్యాలిక్యులేటింగ్ ద ఏరియా. ఇండివిజువల్గా ఈచ్ అండ్ ఎవ్రీ డివిజన్ ఇండివిజువల్గా క్యాలిక్యులేట్ చేసుకొని వేయాలి. ఓకే, and next coming to the meridian distance. So it was there or not? Okay. Okay. So meridian distance. Already I told you meridian distance that is based on the one of the meridian line. There is a true direction of the north or x or y directions. So based on that, they have given as a meridian distance. That means half the length of the distance. Departure అంటే మనం ఒక meridian line డ్రా చేసుకుంటున్నాం. There is a y axis, right? ఆ y axis ని బేస్ చేసుకొని ఎంత డిస్టెన్స్ లో ఉంది. సో నిన్న ఒక ఫిగర్ డ్రా చేసుకున్నాం. దానికి కలర్, ఐ మీన్ Murli has taken one of the image also, I mean screenshot, right? So అంటే అక్కడ మనం ఏం చేస్తున్నాం, we are going to calculate the distance. If you have AB distance was there, AB line, instead of that AB length, what we are doing, we have to take in a horizontal distance, that is a departure distance from the meridian itself. That means it was started from the point of A, right? Meridian distance we have taken as a 0 at the point of A, and next coming to the departure distance from the meridian line itself. What is the distance from meridian to the B point? Okay, that the departure distance at the point of A is 0 because it was started at the along the point, right? Next, now we are going to take the distance from meridian to the point B, that we have taken as a D1, departure distance D1, capital D1 we have initiated, right? After then what we are doing, exactly we have located the midpoint of the line AB. Okay, located the midpoint of the line AB, then taken the distance, that means half of the departure distance, right? So half the departure distance we have indicated with letter m1, that is the meridian distance of the line AB. Okay, m1 equals to, what is the value right now, m1 equals to half of D1. Okay. So half of D1 is completed. There is a meridian. Next coming to the BC line. Okay. Already you know the distance from meridian to the point B. That is M1. Next, BC distance. BC departure horizontal distance is M2. Okay. Now you have to look at the midpoint of the line BC and ensure the distance. Okay. So there is a half of D2 from the point of B to midpoint, right? Okay. So half of the distance is half D2, right? Next, you need to calculate the M2. M2 means from the meridian to the center of the line BC. Okay, meridian to the center of the line BC. That means M2 equals to D1 plus half of D2, right? M1 plus half of D2. That is the distance of the second meridian. That means M2. Okay, next. Now the meridian line was shifted from the point A to C. A నుంచి C shift చేసాం. Okay, based on the line C, అంటే we are going to take the departure distance we have taken from the shifted meridian line. But M1, M2, M3, M4 are we have to take it as a what we have decided the meridian. From there itself, you have to take the distance. Okay. So CD, as we have initiated, there is a horizontal distance is D3, right? Within that, half of the distance is half D3. Okay. So half D3 means from the base onwards. That is meridian onwards means M4 plus half of D3. That is the M3 value. D4 plus half of D3. So that is the M3 distance. Next, M4 is half of D4. Like that, we have calculated the meridian distance. M1 equals to half of D1, M2 equals to D1 plus half of D2, M3 equals to D4 plus half of D3, and M4 equals to half of D4. Right? Now, we are going to calculate the meridian distance of any line. Right? The meridian distance of the any line is equal to the meridian distance of the preceding line plus half of the departure line. Okay, so that means M1 అంటే half of the D1, right? అంటే preceding లేదు కాబట్టి 0 plus half of D1. M2 equals to D1 plus half of D2. So based on the values of meridian distance, so they have given one of the definition, that is, I mean, we have given you one of the equation. The meridian distance of any line is equal to the meridian distance of the preceding line. Okay, preceding line plus half of the departure of the preceding line plus half of the departure of the line itself. Next, area by latitude and meridian distance. Now, as you know, how you have calculated the meridian distance M1, M2, M2, so on. And vertical distance. Vertical distance in the sense that is a latitude, horizontal in the sense departure, right? Area equals to latitude L multiplied with M, latitude multiplied with meridian. Then you will get the area. Okay, so that means if you need this kind of area, A equals to summation of L with respect to M, latitude plus M. So small m in the sense there is a meridian distance. Capital M we are going to indicate for double meridian distance. Okay, when we are going to calculate the double meridian distance, the line is equal to the sum of the meridian distance. The line is equal to the, so that means capital M1 equals to meridian of A plus meridian of B. Capital M1 equals to meridian of A plus meridian of B. So as you know, M1, capital M1, that means double meridian distance. Meridian of A is 0. So because the meridian at the point A itself is started. Okay. Next, meridian of B is distance departure. Right? Departure is D1. That means 0 plus D1. Meridian distance is small m equals to half of the D1. Capital M1 equals to D1. That is the double meridian distance. It is not an important thing. Why? You just leave this one. Okay. And as you know how to calculate the area by coordinates methods. So this is not in your syllabus. Just I'll give you one of the thing how you are going to calculate the area by using of coordinates. Okay. Just assume x1 comma y1 or x2 comma y2, right? So these are the coordinates for the point of a b c respectively, right? And that means x1 y1 is for the point of a, x2 y2 is for point b, right? Like that. If in case of it was there in a irregular shape, we don't know, just you know the coordinates, right? As you know, if you know how to calculate the area for different geometrical shapes itself. That means if you have a irregular boundaries was there, in that case, try to implement possible way of geometrical shapes itself, right? So if you know the coordinates of the each and every point, right? So again, based on the coordinates, what we are doing is we need to calculate the distance of the each and every side and form a one of the triangle if possible, right? If possible, form a triangles and calculate the area based on the coordinates. Already they have given x1, y1 is for the coordinates for a from based on x and y direction. That means meridian distance. Y is the meridian and x is the departure and latitude, right? If you want to calculate the area, that means as you know how to calculate the area, half into base into height. Base means y1 minus y2, x1 plus x2 or x1 minus x2. Like that you have to use and calculate the area here. Okay. From this we have completed the second unit and some of the example problems was there related to the area calculations. Okay. Using of offset methods. Okay. If possible, I will give the questions for this and just work out the problems. Okay, so take this is as a assignment for you. Okay, I will send this send the questions for the ordinates and I will give the example problem also. Just go to that one and calculate the area for the sections. You will get the idea how we are going to calculate the areas. Just there is a very simple, just use the formula. If you are going to use the Vidonic or average or trapezoidal or Simpson's rule, any one of the method, just you know what is the formula, how we are going to calculate the area. That's it itself. What is the basic thing is, you need to know the ordinates for the what is it, mid ordinate and average ordinate rule has to know the ordinates as we have considered at center of the division. Whereas coming to in the Tripsora and Simpson's rule, we are going to start with O naught, right? So O naught itself, and it was taken at the point of started and ended of the division. Okay, so there is a difference in between the mid ordinate and Tripsodal or Simpson's rule. Okay, నేను ఏ పీపీటీలో చూసి చెప్పాను, దేంట్లో చూసి చెప్పాను మీకు ఆ ఇమేజ్ డబుల్ మెరిడియన్ డిస్టెన్స్ అనేది? ఎవరికన్నా ఐడియా ఉందా? వెళ్ళండిమా. ఓకే, సో మీకు ఏమైనా డౌట్స్ ఉంటే చూడండి, నేను అది నోట్స్ ఇమేజెస్ సెండ్ చేస్తాను మీకు, రైట్? సో ఆ ఇమేజెస్ చూసి మీరు ప్రాబ్లమ్స్ అనేవి క్యాల్కులేట్ చేయండి. ఒకవేళ ఇన్ కేస్ ఆఫ్ మీకు డౌట్స్ ఉంటే నన్ను పర్సనల్గా కాంటాక్ట్ అవ్వండి. అదర్వైజ్ రేపు మళ్ళీ మార్నింగ్ క్లాస్ ఉంటుంది కదా, సో అప్పుడు డిస్కస్ చేద్దాం. ఓకే, ఓకే, డౌట్స్ ఏం లేవా? లేకపోతే అటెండెన్స్ పోస్ట్ చేసి లెఫ్ట్ అయిపోవచ్చు.